Our galaxy, the Milky Way, is a sprawling expanse of cosmic wonder, stretching across more than 100,000 light-years and containing hundreds of billions of stars. Each of these stars is a potential sun to its own family of planets, and the possibilities for what might exist out there are truly staggering. As we gaze up at the night sky, we are looking at just a tiny fraction of the stars that make up our galactic home. For centuries, humans have wondered what lies beyond our solar system and whether other worlds might harbor life or even civilizations of their own. Among this vast cosmic ocean lies a star system that has captivated the attention of astronomers and dreamers alike: TRAPPIST-1. This unassuming red dwarf star, faint and cool compared to our sun, might not look like much at first glance. But what makes TRAPPIST-1 truly extraordinary is not just its existence, but what orbits around it. In 2017, scientists announced the discovery of a remarkable planetary system circling this tiny star, and the news sent ripples of excitement through the scientific community and beyond. Located just 40 light-years away from Earth, TRAPPIST-1 is a relatively close neighbor in astronomical terms. To put that in perspective, if our galaxy were the size of North America, TRAPPIST-1 would be like a city just a few towns over from us. While 40 light-years is still an immense distance by human standards, it is close enough that our most advanced telescopes can study the system in detail, and perhaps one day, our descendants might even dream of visiting it. This proximity puts TRAPPIST-1 within reach of our most powerful telescopes, both on the ground and in space. Astronomers have been able to observe the system with unprecedented clarity, using cutting-edge technology to analyze the light from the star and its planets. These observations have revealed a wealth of information about the system's architecture, the composition of its planets, and even hints about their atmospheres. The ability to study TRAPPIST-1 in such detail has opened a new chapter in our quest to understand the universe and our place within it. The discovery of TRAPPIST-1 caused a sensation in the scientific community. Researchers around the world were thrilled by the prospect of studying a planetary system so different from our own, yet so tantalizingly close. The announcement made headlines across the globe, sparking the imagination of scientists, science fiction writers, and the general public alike. For many, TRAPPIST-1 became a symbol of the new era of exoplanet exploration, a time when we are no longer limited to studying our own solar system, but can reach out to distant worlds and begin to unravel their mysteries. What set TRAPPIST-1 apart was not just the presence of planets around another star, but the sheer number and nature of those planets. 7 rocky worlds, all roughly Earth-sized, orbit this tiny star in a compact, harmonious dance. Several of these planets lie within the so-called habitable zone, where conditions might be just right for liquid water to exist on their surfaces. This raises the tantalizing possibility that some of these worlds could be home to life, or at least possess the ingredients necessary for life to arise. TRAPPIST-1 offered a tantalizing glimpse into a planetary system unlike our own, raising profound questions about the possibility of life beyond Earth. Could these distant worlds harbor oceans, atmospheres, or even living organisms? What would it mean for humanity if we discovered signs of life so far from home? As we continue to study TRAPPIST-1, we are reminded that the universe is full of surprises, and that the search for life beyond Earth is only just beginning. At the heart of this fascinating planetary system lies TRAPPIST-1, a star that stands in stark contrast to our own sun in almost every way imaginable. While our sun is a bright yellow middle-aged star that dominates our solar system, TRAPPIST-1 is a much more subtle presence in the cosmos. Its unique characteristics have made it a subject of intense study and curiosity among astronomers and space enthusiasts alike. Classified as an ultra-cool red dwarf star, TRAPPIST-1 is much smaller, cooler, and fainter than our own star. In fact, it's only about 9% the mass of the Sun and less than 12% its radius, making it not much larger than the planet Jupiter. Its surface temperature is a chilly 2,500 degrees Celsius, compared to the Sun's blazing 5,500 degrees. This means that TRAPPIST-1 emits only a fraction of the light and heat that our Sun does, making it appear as a faint, reddish point in the sky even from relatively close distances. Its diminutive size means it emits significantly less energy, bathing its planets in a dim reddish glow. The light from TRAPPIST-1 is not the bright white or yellow we're used to on Earth, but a soft, eerie red that would cast alien shadows and paint the skies of its planets in unfamiliar hues. For any potential life forms, the experience of day and night would be unlike anything we know. Despite its small stature, TRAPPIST-1 plays a crucial role in making its planetary system so intriguing. Its low mass and cool temperature allow planets to orbit much closer than those in our solar system, creating a compact and dynamic family of worlds. In fact, all 7 known planets in the TRAPPIST-1 system orbit closer to their star than Mercury does to our Sun, resulting in a tightly packed system where planetary years last only a few days. Because it's much cooler than our Sun, the habitable zone around TRAPPIST-1, the region where temperatures might allow liquid water to exist, is located much closer to the star. This proximity means that planets don't need to be far away to avoid being scorched, and several of TRAPPIST-1's planets fall within or near this potentially life-friendly zone. This means that planets can orbit the star at a much closer distance, and still potentially support liquid water on their surfaces, a key ingredient for life as we know it. The close orbits also create opportunities for fascinating gravitational interactions between the planets, possibly affecting their climates and geology. Altogether, TRAPPIST-1's unique properties make it a cosmic laboratory for studying the possibilities of life beyond our solar system, and a reminder that not all stars, and not all planetary systems, are like our own. Orbiting this dim red sun is a remarkable family of 7 Earth-sized planets, a discovery that sent ripples of excitement through the scientific community. These planets, all roughly the size of Earth or Venus, are packed tightly around their host star, with orbits much smaller than that of Mercury around our Sun. This close proximity of the planets to their star, and to each other, has profound implications for their potential habitability. The planets are likely tidally locked to TRAPPIST-1, meaning that one side of each planet permanently faces the star, while the other side remains shrouded in perpetual darkness. Out of the 7 planets discovered in the TRAPPIST-1 system, 3 stand out as particularly promising in the search for extraterrestrial life: TRAPPIST-1, E, F, and G. These planets reside within the star's habitable zone, the region around a star where temperatures could allow liquid water to exist on a planet's surface. The presence of liquid water is considered one of the most crucial factors for the emergence and sustenance of life. While the habitable zone doesn't guarantee the presence of life, it does significantly increase the odds, making these 3 planets prime targets for further investigation. Among the 3 potentially habitable planets in the TRAPPIST-1 system, TRAPPIST-1e stands out as particularly promising. This Earth-sized planet orbits within the habitable zone and is believed to be rocky, like Earth, rather than gaseous. While much remains unknown about TRAPPIST-1e, its size, potential for liquid water, and proximity to Earth make it an exciting target for future observations with telescopes like the James Webb Space Telescope. Scientists are, really eager to learn more about its atmosphere, surface temperature, and potential for harboring life. The close proximity of the TRAPPIST-1 planets to their star results in a phenomenon known as tidal locking. This gravitational interaction causes the planets to rotate at the same rate that they orbit the star, meaning that one side of each planet permanently faces the star, while the other side remains in perpetual darkness. This tidal locking could have significant implications for the climates of these planets. The side facing the star would experience perpetual daylight and likely scorching temperatures, while the side facing away would be trapped in an eternal night. The TRAPPIST-1 system, despite its distance from Earth, offers astronomers a unique opportunity to study exoplanets in detail. This is due to the system's orientation relative to Earth, which allows us to observe the planets as they pass in front of, or transit, their host star. As a planet transits its star, it blocks a tiny fraction of the star's light, causing a slight dip in the star's brightness. By carefully measuring these dips in brightness, astronomers can determine the size, orbital period, and even some information about the atmospheres of these distant worlds. The discovery of the TRAPPIST-1 system has opened up a new chapter in the search for life beyond Earth. This remarkable system, located about 40 light-years away in the constellation Aquarius, has captured the imagination of scientists and the public alike. For the first time, astronomers have found a planetary system with 7 Earth-sized worlds orbiting a single cool red dwarf star. The excitement surrounding TRAPPIST-1 is not just about the number of planets but also about their potential to host conditions suitable for life. Each of these planets offers a unique opportunity to study worlds that are both similar to and different from our own. This unique system with its 7 Earth-sized planets offers a cosmic laboratory for scientists to study planet formation, atmospheric evolution, and the potential for life to arise in environments vastly different from our own. The close proximity of these planets to their host star means that they complete orbits in just a few days, allowing astronomers to observe frequent transits and gather valuable data about their atmospheres and compositions. Some of these worlds lie within the so-called habitable zone, where temperatures could allow liquid water to exist on their surfaces, a key ingredient for life as we know it. By analyzing the light that passes through their atmospheres during transits, researchers can search for signs of water vapor, oxygen, and other molecules that might indicate biological activity. By studying the TRAPPIST-1 planets, we can gain insights into the diversity of planetary systems in the universe and the factors that contribute to a planet's habitability. Each planet in the system has its own unique characteristics. Some may have thick atmospheres, while others could be rocky and barren. This diversity allows scientists to test theories about how planets form and evolve, and to explore the range of environments where life might emerge. The TRAPPIST-1 system challenges our understanding of what makes a planet habitable, and expands our perspective on the possibilities for life elsewhere in the cosmos. This knowledge will help us refine our search for life beyond Earth, and understand the conditions necessary for life to flourish. As we continue to explore the TRAPPIST-1 system with powerful telescopes and innovative technology, we move closer to answering some of humanity's oldest questions. Are we alone in the universe? What makes a planet truly habitable? The discoveries made here will not only shape the future of planetary science, but also inspire new generations of explorers and dreamers to look up at the stars and imagine what other worlds might be waiting to be found. The TRAPPIST-1 system continues to be a subject of intense study, with new discoveries emerging all the time. Recent observations have revealed that some of the planets likely don't possess thick hydrogen atmospheres, suggesting they might be rocky worlds like Earth. Scientists are also studying the effects of stellar activity such as flares on the planet's atmospheres. These flares could pose challenges for life but could also provide energy sources for potential life forms. As we continue to explore the TRAPPIST-1 system, we can expect even more exciting discoveries in the years to come.